So a very good evening to all present here, honorable guests and dear authors. I, Sumanj Barwal, moderator of this session, welcomes you all to the technical session 6A. And on behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on ICT for Sustainable Development, Goa, India. This 8th edition of the conference is being organized in a hybrid mode. The physical event was held in Goa on the 3rd of August, and the virtual event is being held through Zoom today and tomorrow. That was the 3rd and 4th of August. I hope that you all will enjoy the knowledgeable and interactive sessions throughout the day. So before proceeding, let me tell you how the session moves. So in this session, we are having total of 7 presentations, and each presenter will be given 8 minutes for their presentation and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder so that you can conclude your presentation as soon as possible. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. So just before we get started, let me introduce you to the chair for this session. So for this session, we have Dr. Geeta Nawale. Ma'am, I hope I have not mispronounced your name.
Yeah, Navle. It's Navle.
Sorry for that, ma'am. Geeta Nawale.
Yeah.
So and the chair for this session is Geeta Nawale. She is currently working as a professor and head of Department of Computer Engineering in Singhar Institute of Technology and Science, Pune, Maharashtra. She has teaching experience of 24 years and 30 plus international journal publications. She has also been a part of 20 plus international and national conferences and has 3 patents. It is a great pleasure to have you here with us, ma'am. Would you like to say something before we proceed with the authors?
Okay, thank you. Thank you so much for your kind introduction.
Thank you.
Yeah. No, as already you have given instructions, we will go as per that.
Okay, ma'am.
Yeah.
So before the meeting started, actually, Dr. Sudhakar Kian sir requested me to give him the first preference because he has some work. Sudhakar sir, are you there?
Yes, I'm there. Thank you.
So, sir, you may share your screen and we'll start with you, sir.
Yeah, okay. Thank you for considering mine. Okay.
No problem, sir.
My screen is visible?
Yes, sir, it's visible. You have 8 minutes and you may start.
Yeah, okay. Good afternoon. I am Dr. Sudhakar. I have done this paper is being authored by myself and 2 of my students. That is Hari Pranav and Gokul. The topic of my paper is intelligent filter for traffic monitoring and analysis for cyber threats. So this is basically concentrating on actually understanding the traffic, the incoming traffic which is coming through and going out in all our personal devices. So as we are being exposed to a lot of surfing over the net, so sometimes we may not know that what kind of request responses are leaving or coming inside our particular system. So the whole model that we have built is basically monitoring it and trying to analyze that whether is there any kind of malicious attack or some particular third party some kind of a machine which is trying to connect you and your particular system is compromised. So basically the whole problem is related to finding a solution of monitoring the personal devices like your computer, mobile, whatever devices that we use. The main aim is to get a clear understanding of what kind of a traffic is inflowing and outgoing, and having a clear picture about that whether your particular device is compromised and what kind of data is being moving through and going out. So that is the major view of the particular problem statement. And the solution that we have provided is what we thought is something like have we been Pod is a kind of site where we can actually check whether our emails are being used or some kind of phishing or it's been compromised. So there's a site like that. So we wanted to create a portal where we can actually check whether our particular machine is being compromised. So basically, we are going to use the intrusion detection system. So we have different kind of intrusion detection systems, which is signature based, anomaly based, and network-based intrusion detection system. So which has now whenever we say we are trying to filter out a particular kind of a threat might be based on some kind of a signature or some kind of a behavior, or it can be also understood like when there is a high rate of inflow or high rate of outflow. So basically these kind of observations, when we continuously monitor the internet traffic, we get some kind of analogy and try to figure out that whether when this kind of a behavior is being observed, can we actually have a study on that and try to find out whether this kind of a traffic is coming from a legitimate user, or it is being used by somebody who is actually trying to fish into your machine or trying to steal something or some kind of. So basically this whole thing is basically monitoring the traffic which is going out and in of a particular machine. And as we are being exposed to such devices which all are connected to internet, so we are always in a verge of only getting our work done, but in that particular situation, we may serve certain sites which has some malicious files or some kind of a JavaScript or some kind of a scripting scripts which gets downloaded when you actually surf, and they actually start fishing in your particular content outside, and there can be some kind of a signatures which comes out. So the overall thing is understanding this and trying to build a dashboard is the major aim. How we did it is now we know that there are some we actually stick on to the open source ideas. So we have found like there are few out of which Snort, Suricata, and Zeek. These are few things that we found to be an open source environments of intrusion detection system, which are open source and freely available. So we use these tools to actually figure out that how this traffic is flowing, how much this traffic is flowing, and in what mechanism this particular data is flowing. So we built a model. So how we built a model is basically like we tried with finding it a cloud solution, because this needs a lot of computation to first actually put on all these tools on a cloud platform, and then making sure that whatever traffic it is coming, incoming traffic, we read out all those things, and then once again come to a conclusion that whether a particular network traffic is proper or appropriate or not. Later we got to know that we can actually deploy, we can actually find out another alternative and try to we try to deploy it on a Docker. So the overall system, actually this was a web platform that we tried, and so these are some of the tools which we have used to create. First thing is understand the whole content, and then try to build a dashboard. And this set of dashboards we can visualize and try to identify that what kind of a problem may arise. So I'll just show you with a diagram. These steps is basically like how we are actually tried this. So as we are using a lot of open source tools, these open source tools has compatibility issues. So we try to take the right appropriate version and try to put onto a virtual environment like Docker. And we try to make sure that the dashboard, all this set of softwares, whatever is that, they interact well and try to give us a good visual appearance of the whole thing. So how does this whole model actually work is like, as we know that we have there's a software called as Wireshark. Wireshark, we have used it to capture all the PCAP files. So basically it is we try to capture all the packets which is flowing through the network via Wireshark, and create a PCAP file, where PCAP file will have a list is being built up for a huge period of time, so that we have the complete list of what was incoming and what was going out. And that particular Wireshark, whatever values is being read in, and that particular data as in the form of a PCAP files is being given to Suricata and Zeek, which actually does the which are basically two differently enabled intrusion detection systems. So they analyze this particular content and how they actually predict and how they actually process this whole data. That particular information is being fetched to a different set of tools, which actually create a dashboard out of the understanding of whatever the Suricata and Geek have generated the analysis, that whole analysis is being built into a visual form. And this visual form is it's possible to build a dashboard, where by seeing that particular dashboard, you can have an analogy that whether your particular device is compromised, which particular device it is coming from, whether it is a legitimate one, whether he is using we can also understand like which particular operating system is used, and who is the one, and which particular area is being with. So this particular information, actually we get it from the packets which has been moving around in the network. So that information itself is being analyzed by the Suriketa and Geek. That is being given to a visualization tools, which is Logstash, Elasticsearch, and Kibana, where Kibana is a visualize and a managing tool, and Elasticsearch is a search and analysis. So whatever data, so it's basically like the whole information is given to Logstash, and that information is being fetched to search and analyze to Elasticsearch, and that information is given to Kibana. So so whatever information we have got into Kibana, that we get a like a web interface where we can actually have all the visualization graphs. By seeing them, we can actually have a clear understanding that that whether your particular devices has been compromised, or it is neat, or everything, the traffic flowing in and traffic going out of your particular machine is legitimate. So we have done run few set of tests.
Sorry to interrupt, sir. Sir, it's time. Can you please conclude? Yeah. Okay. So basically, nowadays people are trying out with different kind of tools to actually peep into a particular system. So here, every individual has a possibility of finding whether your particular system is compromised. That is the whole agenda of the whole paper content that we are tried with, and we have come with some live solutions. So I conclude here. Ma'am, do you have any questions for sir?
Yes, yes. Hello, sir.
Yeah, ma'am. Good evening, ma'am.
Yes, good evening, sir. While implementing, do you face any problem?
Ma'am, actually the problem is there are open source tools. These open source tools has a versioning problem. One particular version does not match with the other version. So there is a as they are independent tools, when we are generating a data from one particular tool, and that data we are fetching to the other one. Okay, actually they have a compatibility issue with the operating system itself. So for example, now I have the latest version, which is having a lot of signatures and all of it, and I want to match with the other one. Now, what will happen is the other one does not support the latest one. So because if that particular tool is not updated to the latest state, so what will happen? There is a conflict. So this was the major problem that we actually came across in setting up the whole system itself. So that's why we try to find out the right versions which actually can go through, and that was the reason we used Docker, so that the platform issues does not come in. And one more thing is, like, we wanted this whole thing to run on a high power machine, because the data which will come will be we are going to have a few months data. So that will be a huge files, and there's a lot of every particular packet information has to be filtered, and it has to come with the statistics. But for the sake of completion of this, we tried with our own machine, and with some of the files which is already existing in on internet for testing purpose. Ma'am?
And what's the reason behind choosing Wireshark? Why not any other?
Ma'am, Wireshark is once again it's a free tool, and it is a free tool, and it is widely used by in the people who are into networks. They use it for many purposes, and Wireshark is being free. Most of our vision was popular and free. That's the reason that we went with Wireshark. And we can do a lot of analysis. It is a great tool to get whatever information that we want.
What I mean to say is, only free is the criteria to choose?
Actually, not the free, ma'am, because proprietary tools are quite costly. So, and thing is, like, as being a proprietary tool, how much we can test with it, that matters. So as we being an educational institution, we prefer to go with the tools lot more to experiment, because each of these tools itself, if they cost, then doing an analysis overall, the whole process may not suffice. So we thought of going with all the tools. And usually in the community of cybersecurity, many tools are actually open source. But whatever proprietary are there, they are like usually companies buy them. Institutions, I think they never procure them.
Okay, sir. Thank you so much. Thank you.
Thank you, ma'am. Thank you very much.
Yeah, thank you.
Thank you, Sudhakar, sir.
Thank you. Thank you very much for giving me the first slot. Thank you, boss.
No problem, sir.
Thank you. So I have to leave for an urgent thing, so I can leave, right?
Sure, sir. Yes, you may.
Yeah. Thank you very much. Thank you. Bye.
So next up, we have Inian K, and his paper title is Bluetooth Automated Wheelchair. Are you there? Inian K. I hope I'm not mispronouncing you. Okay, so let's move to the next author. He's not here. So we have Vadha Alphanes. I hope I have not again mispronounced your name. And the paper title is Crop Recommendation Assessment for Arid Land Using Machine Learning. Vadha, are you here? Can you hear?
Yes, we are here. We are ready for present.
Okay, is someone else presenting on behalf of Vadha?
Yes, me.
Okay, you may please present.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everyone. My name is Noura. Today I'll present the crop recommendation assessment for arid land using machine learning. My team are Batul, Wadha, Isra, supervised by Professor Suresh from King Faisal University. The agenda for today, we will start with introduction, then we will discuss the crop recommendation dataset, then data visualization and analysis, followed by model performance, ending with conclusion. Introduction. Food and farming are two of the most important sources of live food for most people in the world. With the escalation of climate change, it is becoming increasingly important for farmers to optimize their production in order to maximize their yields and reduce their cost. Farmers in arid regions face some challenges, such as low rainfall, also erratic rainfall pattern, and the last one is live soil with poor water holding capacity. Machine learning algorithms are examined as a means of recommending crops in farming system. By using machine learning technology, large amount of data can be analyzed, automated, and real-time predictions can be made without the involvement of humans. Crop recommendation dataset. We will discuss the dataset. The dataset contains of 8 columns, 2,200 records, and 17,600 fields. The columns are nitrogen, phosphorus, potassium, temperature, humidity, pH, and rainfall, and the last one is the label, because we are targeting classification problem. This is the visualization of the dataset, which shows the correlation. The correlation here shows the relationship between features. You can see that the dark colors show the strong correlation, as in diagonal, while the light colors shows low correlation. This is a diagram for showing the missing values. There is no missing values. As I mentioned previous, that the number of columns are 8 and the number of records are 2,200. This is the result of the model that we are training them. We have evaluated 5 machine learning models. And knife bias algorithms towards crop recommendation. Different crops based on features correlated. The models have been evaluated in terms of accuracy, precision, recall, and F1. The result shows that the random forest with the highest accuracy of 99.45%, followed by knife bias, then SPC, then decision tree, then KNN, respectively. We chose the best model, which is random forest, based on accurate result, because the crop recommendation dataset is balanced, which calculates the ratio of a correct prediction made by the machine learning model over the total number of instances evaluated. This is more visualizing of the accuracy. And it shows that the random forest has the highest accuracy among the rest of the models. Conclusion. In the future, this work can explore different approaches, such as the more sophisticated machine learning algorithm like deep neural, with optimization for a better accuracy of the recommendation system. The system can be integrated with a crop yield prediction for providing better productivity. Additionally, the system could introduce larger dataset with various features, such as market prices, weather forecast, and etc., to improve the system predictive accuracy. We reached to the end of our presentation. Thank you for your listening, and we are ready for your questions.
Hello,
Do you have
ma'am.
any questions for Nora?
Yes, no questions, no questions.
No. Thank you so much, Nora and Vadha.
You're welcome.
So we'll move to the next author. And next up we have Abhijit Kamble. And his paper title is Eye for Blind, a deep learning based sensory navigation system for the blind. Abhijit Kamble, sir, can you hear me?
Yes. Hello, everyone.
Hello, sir, you may please present your screen.
Yes. Good evening, all. My name is Abhijit Kam from Vishwakarma Institute of Technology, Pune. So, today's topic is paper title is deep learning based sensory navigation system for the blind. Paper ID is 120. So authors are Sahil Kakurle, me myself Abhijit Kamble, and Manish Shetkar. So through all these, our supervisor Professor Machudre. So today's agenda: introduction, literature survey, research here, novelty, and advantages and limitations, and then final conclusion. So introduction. The WA has reported that approximately 285 million people are visually impaired worldwide. So out of these, 9 million are completely blind. So for them to carry out the daily activities, like such as one of them I have written reading, and then so our project is that deep learning and computer vision advancement have resulted in the development of several technologies like that here can help for visually impaired people, such as object detection tools and text to speech system. So CNN has shown great promise, particularly in the image recognition and object detection. So our approach utilizes a CNN model to recognize images and generate audio files, audio feedback with the descriptive labels. Then blind system, visually impaired individuals will be able to navigate their surrounding more effectively and efficiently. So eliminate their dependence on assistance from others. So we have our system architecture and it's with the AMS code. Next, literature survey. So we have almost 10 to yes, we have shown here the three of these papers. So in first of paper that understanding of the convolution neural network. So in this paper we have studied all about the convolution neural network model and each and every parameters of that convolution neural network. So how can we extract the images accurate data? So paper is a student lesson learned from the 2015 MS Coco Image Captioning Challenge. So in this paper we have studied that all techniques, models, part, and then paper is that overview of image. Is all there is literature review. Then coming the research gap. So I think what is the difference between already devices or projects already have in market and in our project? So they are and heavy systems. So they are systems and it has low accuracy. So they have studied all that problem and got through the novelty of our project. So our project novelty is able to work outdoor. So is stable and visually impaired people can handle easily. And then it can be real-time implementation. So just capture the image and get the audio file in feedback in descriptive format labels. And it is cost effective. And next, as I have mentioned, portable and lightweight system, and it has good accuracy. Then coming to the methodology. So in methodology, we developed a model that generate captions of images by combining neural network architecture. One of this is convolution neural network, and second is the RNN, which is a recurrent neural network. So a convolution neural network is adept at processing data with 2D matrix like a structure, making it ideal for extracting feature from images. So it commonly used for image classification tasks, identifying object, and the CNN scans the images by combining important features to make classification even for images that are translated or rotated, scaled, or viewed from the different perspective. So it contrasts that the LSTM means the long short-term memory is a type of, as you know, the recurrent neural network that is sustainable for arranging estimated task. So you can predict the next word based on the earlier text, and it is more effective than the traditional RNNs because it overcomes the short-term memory limitations. So by combining the strength of CNN and LSTM, our model generates neural language description of images by describing object attributes relationships. And coming to the data set and so in our caption image generate project, we have opted to use the flicker rate as it's smaller and it can be trained in a reasonable amount of time. So the flicker 8K dataset comprises 809 images, each with 5 corresponding descriptions, despite various scenes and situations. So we have addressed data into 3 sets. 6,000 images for training, 1,000 images for validation, and 1,000 images for testing also. And each image having varying dimensions. So then import data. So data frame is created to summarize the images ID, file path, and associated caption. Each image ID in the dataset have 5 caption associated with it. As a result, number of samples would be 40,455. Then coming to the data cleaning, next step. Data cleaning is the process or techniques such as that removing punctuation, converting text to lowercase, and eliminating numeric values are commonly used to the clean text data. The next step is the data processing. So in natural language processing, pre-processing is crucial before training and training any model. So caption pre-processing involves tokenization caption, limitizing the vocabulary to the top of 500 words, replacing unknown words with the UNK token. So it will help to the pre-process. Then the dataset creation. For building dataset, function is created which maps the image path to their feature. And this function is then applied using a builder function to create the train and test dataset. So then next step is the data evaluation. So this study focuses on developing a deep learning model that generate image caption by combining convolution and recurrent neural networks. So block diagram.
Sir, it's time. Can you please conclude as soon as possible?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. So these are advantages and limitations. So limitations are blurred or noisy input images can be lead to wrong prediction and unable to classify that images. So this is a result as shown that given that image and how the image can extract the feature and gives the required name. That man is wearing mask, holds up to boy's hands of water from water. So this is the result, and we get the audio as well in descriptive format. In the conclusion, we have been developed a neural network model which combines two architecture, convolution neural network and long-term memory network to produce natural language descriptive for images. So it is based on multiple CNN. So is effective for recognizing and extracting object from images as well as the generating caption depending on the provided. So this both CNN and RNN model are used in the order to get accurate result and to find the relation between objects and images. Numerous application can be made with this model. So these are the references, and thank you.
Hello.
Yes, ma'am. Any questions for sir?
Yeah.
Yes.
Yes. You already mentioned that good accuracy can be maintained or can be generated using your approach. So
Yes.
let me know what was missing in the older approach so that they were getting the less accuracy.
Yes, ma'am. So basically what happened in our model, we have used the LSTM model, then attention mechanism. So basically, while working our this image captioning generating project, we encountered the challenges related to that model attention mechanism. So for that generating caption, we have something inaccurate or poorly aligned with the silent images feature. To resolve this, we have carefully analyzed the model architecture and reviewed the relevant research paper and conducted rigorous tracing with the different attention mechanism and also that hyperparameter configuration. So basically we was able to fine tune that model and improve the alignment between the image and generated caption. So basically we able to enhance the overall performance.
Okay. Thank you so much. Yeah.
Yes, ma'am. Welcome.
Yeah.
Thank you, sir. Thank you so much. We'll move to the next author now. Next up, and next we have Sudhakar sir has presented. So we have Harsh Modi. And his paper title is Neural Transfer of Style Learning and its Application. Harsh, are you here? Harsh? Fine, we'll move to the next author now. We have Raghava Simhan TV, and his paper title is Real-Time Suppression of Non-Stationary Noise for Web-Based Calling Applications. Raghav Simhan, are you here?
Yes, I'm here.
Sir, you may please present your screen and start with the.
Sure. Might need a moment to share. Thank you for waiting.
Take your time.
So excuse me for the delay and thank you for the opportunity. I'm here to present this paper on behalf of all the authors of the paper Real-Time Suppression of Non-Stationary Noise for Web-Based Calling Applications. Please move on to the next slide and let me explain the title and the terms relevant to this to provide some background. So I have spoken about non-stationary noise. So this begs the question of what is noise, and what I'm talking about is the noise that comes from the background of any call that we speak. Some noise must be provided there in the side of the speaker or the person who is recording the audio, and this noise can be categorized as two. Please move on to the next slide. I will come back here for the details. As stationary and non-stationary. Stationary noise is the ones that like the fan that is spinning in the background, some noise that is consistently there in a rhythmic manner. It's going to be there. It's not going to change with time. And there is non-stationary noise. So like suddenly a dog is barking or howling in the road, and it's or an ambulance is passing by the house and some sound is being heard on the other side. So what we are trying to do is try and reduce this non-stationary noise. And now the challenge that comes with it is that it is not easy to model. A constant noise is easy to model because it is going to be in a very similar manner. It's going to come in the same frequency in a rhythmic manner. We can identify it, we can model it mathematically, and we can remove it off easily. But this non-stationary noise, this is going to cause some more difficulty. So what is even more of a challenge is that it has to be done in real time. Now, when it comes to a question of real time, computations have to be performed in a fast manner. For that, the device must have the capability. For that, the network must have the support. For example, now I couldn't even share my screen. So this kind of devices must support this additional feature. So in web-based calling applications is what I was talking about. When it comes to web-based calling applications, it's like Zoom or Microsoft Teams or what we are using right now and all these things that became prominent during the pandemic. It is here to stay. We are using this only prominently now. So in these applications, we need to have this noise suppression to ensure better things. So why are we taking this specific particular thing is because in mobile phones, there is a hardware method of reducing noise. So when we speak our regular phone calls, they have a hardware a system in place which is reducing the noise. Filters are in place in the mics. Similarly, if you take high-end mics or high-end headsets, these are present already in the hardware manner. What we are trying to bring in is a software approach to resolve this non-stationary noise. And I have to insist one more thing here. This is not, please move on to the next slide. This is not the same as noise cancellation. So we are talking about noise suppression here. Noise cancellation is what you experience in your AirPods probably or some other popular earphones. Is that you don't hear your noise in the background. So that is on the speaker side. On this, for a person who's wearing the earphones, they will not endure the noise that is there in their background. But for noise suppression, the problem statement is the far end user should not see the noise. For example, if there is a dog barking in my outside my house, then you should not be able to hear that sound. Then my system is successful. So this is the scope of this project. Let us proceed to the next slide. So there are three objectives that we took up when we started with this project. First thing is portability. As I said earlier, there are some high-end earphones or mics that support, or if you go to a studio and record, there is going to be a lot of noise suppression that is brought up by the setup of the studio and all that. We don't want that. We want anybody, with any kind of device, they should be able to utilize noise suppression. They should be able to exploit this system. Next thing is quality. Just because we are going to support portability, we should not compromise on quality. Some compromises will be there. There will be trade-offs, but we should try and optimize this quality also. And the third one is latency. Now, this is going to happen over a network because web-based calling is our choice of calling application. So in that case, we should ensure that there is less latency, there is no lag when I speak and you hear. In between, there is an application that is running to reduce the noise. The lag should not be there. So these three things, there will be a lot of trade-offs, but we have to optimize these three things and bring out a solution. So please move on to the next slide. So we are going to talk about some of the existing techniques and why we have what the pluses and minuses are. As you can see, the Wiener filter, which is which is actually a very popular technique, is also already used in mobile phones and all. Latency and quality wise, they are excellent, but portability is an issue because in certain hardware only it works out. It requires one mic which will record the noise, one mic which will record the noisy audio, and then there's some subtraction takes place. It's a statistical filter, and some kind of a subtraction takes place, which requires two mics, which is not possible for all devices. Let's take an Alexa device or something that in the future might become popular for calling. We cannot expect the same kind of a device architecture. Next is gated multi-layer perceptrons, which was proposed, which is a combination of many neural networks. Its gating is very similar to a weighted average of all the networks, and it is actually improving the quality a lot. But because of multiple neural networks connected together and all that, there is a lot of computational overhead, which is not favorable. Let's go to the next slide. So recurrent neural networks, these also are excellent for quality. Now the thing about recurrent neural networks, which is it's a very popular problem, is it's computationally very intensive, takes up a lot of memory, and it is not suitable when it comes to portability. For example, when we tried it out, it was working out very well on a recent MacBook with M1 chip, which is very popular for its processing ability. But on another laptop, which is a few years older, with a lower CPU, there was a lot of heating when we tried out. So this is not very portable. Let's go to the next slide. So again, next slide. So what we have is, first we need to develop a video chat application like Zoom, which will which will allow us to introduce this noise suppression. Second, we need a noise suppression module, which is what we have done in this work. Go to the next one. So this is the overall architecture. If you see that having two users and then a stun server to connect them, to signal them, it is the WebRTC, which is a standard way to connect people across the web, to do it in a serverless manner, to have just the server though present is only for signaling. It just says, hey, you connect, he wants to connect with you, and then both of them connect, and then through peer-to-peer connection the information is going on. So there is no privacy issue over here. For example, if you take Google Meet, they have noise suppression in the server. They are able to do this non-stationary noise suppression with a very heavy algorithm, but it runs on custom hardware in Google server, which means all the call audio, video, screen share, everything has to go to Google server, will be stored there. The algorithm will run on it, and then it is passed on. This is not suitable. This is not good for privacy. So that is why here we are going with a peer-to-peer approach. Let's go to the next slide.
Sir, also you have just got 1 minute, so please continue.
Okay, I will conclude quickly. Thank you. So let us skip through this, which is what I've explained already. Let's skip through this slide too. So for the noise suppression module, what we essentially do is the audio stream, we are extracting that separately. From the mic, audio is being extracted separately. From the browser, we are capturing it. And then the pre-processing steps like short-term Fourier transform, these are standard steps which have to be performed. These are performed. And then the algorithm is applied on it. And the post-processing is done, and then it is sent to the other person. So this is a very overall view of it. Let us go into detail and conclude in the next few slides. Please go to the next one. So the major thing here is we have used the DMX architecture, which is an encoder decoder based architecture which avoids doing heavy computations and which is better than an RNN when it comes to computational overhead. So it works in the waveform domain, and encoder basically will do some kind of a dimensionality reduction, which is itself a way of reducing the computational overhead. And then on this dimensionally reduced version, the RNN or LSTM can be run, which is going to have lesser computational overhead. And then the decoder brings it back to the audio signal, which is the architecture of the algorithm that we are using. Let's move on. Let's go ahead further from this. So let's go into the results. Yeah, we can run through all this. So there are two metrics used for evaluation. One is perceptual evaluation of speech quality. The other is STOI. It's a short-term objective intelligibility. You can see that these are both metrics of speech alone. So what we focus on is the speech should be objectively intelligible and should be very clear when the other person is hearing. These are used by hardware manufacturers also for the sake of testing telephones and handsets. And these are ITU recommended standard tests for speech quality. Let's go ahead. So you can see clearly that the DMX and Wiener filter are outperforming the other techniques by a large margin. And this is why the Wiener filter is taken on by the hardware manufacturers to integrate within the hardware, whereas the DMX is suitable for the software approach. And since we are trying to bring about a software solution, we are taking up the DMX architecture. Let's go ahead. And this is to demonstrate that how the audio is denoised. This is how a clean audio spectrogram looks. Let's go to the next one. This is how the noisy audio is, and you can see the white haze over it. Let's go to the other slides. Let's quickly run through them. So RNN does denoise it, but it is not doing a great job. And this is this Wiener filter. If you look at the DMX, the white haze is reduced far more than other algorithms. So this is how it improves the quality. It's very similar to the clean audio. This is the point that this image is trying to highlight. Let's go to the next. So this is about the real-time part of it. On a very low end, you can see that an i5 8th-gen CPU is a slightly older version only. On that itself, there is a very small lag of 41.3 milliseconds. Now, as I said, there are server-side solutions which have a lesser lag, but this is what is done on a lower-end laptop itself, on a client side itself. The main challenge here is that everything that is running in this program should run within the browser itself. It should not take up any of the information to a separate server where the user's privacy is affected. And it should happen within the browser environment, which means lesser resources are utilized. Everything is containerized within the browser. It's isolated, doesn't affect the other programs on the system, and does not overutilize any resources. So let us conclude with this, and I'm open for questions.
Yeah, hello, sir.
Hello, ma'am.
Yes. DMux is, you can say, already source separation model is already present. Is it right?
Yes.
Yeah.
It is from Facebook.
Yeah. So what exactly you did in your this
in the
research?
work.
Yeah.
Yes.
Yeah.
So the main focus of this work, as I told, is to make it suitable for web-based calling. As I highlighted earlier about Google Meet using everything in a server, here we are using everything within the browser itself. For example, you will be knowing about the client-side JavaScript events. If I press a button on a website, it is not individually calling, triggering some other website or some other server. Only if I set it up to call another server, it's going to do it. But a button on a website getting clicked is a client-side event. There is no connection to any other server. There is no request going. There's no response coming in. To set up a plain button on HTML. So that is what we are doing here. Everything here is running purely on the client side. So none of the technologies that are here used, none of these applications like this RNN or your machine learning algorithms, all these things are not available for playing on the client side of a browser. So essentially, we have implemented most of the Python libraries or popular libraries like TensorFlow will be having a lot of APIs for doing your machine learning, right? So these things we have re-implemented in JavaScript. and optimized for doing in the client side, to work fully in the client side. That is the focus of the work.
Okay. Oh, thank you, sir. Thank you so much.
Thank you, ma'am.
Okay, thank you, sir. So now we're moving to the next author. Just a minute. Now we move to the last author of the session, and we have Divyesh Bhatnagar, and his paper title is Survey on Implementation of Machine Learning in Cloud Security. Divyesh sir, can you hear me?
Yes, sir. I can hear you.
Yes, sir. Sir, please, can you share the screen?
Yes, sir. Sure. Sir, is it visible to you?
Yes, sir, it's visible. You may start. You have 8 minutes.
So, very good afternoon to all of you. I am presenting a paper on literature review on survey on implementation of machine learning in cloud security. So these are the contents of my presentation: cloud computing, essential characteristics of clouds, security models, cloud security, security issues with service models, machine learning and machine learning techniques. At the last, we have references. So the cloud computing is the very convenient model that offers on-demand resource with less management, increased productivity, speed and the efficiency, performance and the security, low investment cost in developing infrastructure, providing training or purchasing a new software. So the cloud computing is the delivery of the different services through the internet. These resources includes tools and the applications like data storage, servers, database networking, and the softwares. Rather than keeping the file on the proprietary hardwares or local storage device, cloud-based storage make it possible to save them to a remote database. As long as the electronic device has access to the web, it has access to the data and software programs to run it. The advantages of this cloud computing is backup and restore data, improved collaboration, excellent accessibility, low maintenance cost, mobility, iServices in the pay-per-use model, unlimited storage capacity, and the data security. So let's move on to the next slide, that is the characteristics of the cloud computing. So the first one is the on-demand self-service. Whenever user need any computing capability like network storage, it should be allocated to the user automatically without interaction with the service provider. So next characteristic is that broad network access. By this capability, data can be accessed all over the network. So user can access by any device. So now we can say if we need to find any files, so we can find out through the laptop also, and we can access to the mobile also, like we can say that Google Drive. Now the next characteristic is resource pooling. It removes the foundation of stick to the location data pool to the server, so the data can be accessed by the user from anywhere to any place. So the next one is rapid elasticity. User can get capabilities rapidly, sometimes automatically, and use those capability unlimited and can buy it at any moment of time. So the last one is the measured service. This cloud system is self-optimized and the uses of resource monitored and transparently reported by both the provider and the user end. So these are the various services which is provided by the cloud. That is SaaS, we can know as software as a service. Next one is the PaaS, platform as a service. And the third one is infrastructure as a service. So these are the various examples of the service which are provided by the SaaS, that is Gmail, Yahoo Mail, etc. And the platform as a services, we can consider the online compilers, and infrastructure as a services, we can consider the AWS, Google compute engines, etc. Now let's move on to the next, that is cloud security. The cloud security is the protection of data stored online via cloud computing platform from the theft, leakage, and the deletion. Method of the providing cloud security include firewall penetration testing, tokenization, virtual private networks, and avoiding public internet connections, cloud security is a form of cyber security. So cloud security is essential for the many users who are concerned about the safety of the data they stored in the cloud. They believe their data is safer on their local servers where they feel they have more control over the data, but the data stored in the cloud may be more secure because cloud services provider have superior security measures and their employee are the security experts. On premises, data can be more vulnerable to security breaches depending on the type of attacks. Social engineering is the malware can be may data stored system vulnerable, but on-site data may be more vulnerable since its guardians are less experience in the detecting security threats. So as the cloud computing has three services model like SaaS, PaaS, and IaaS, which is provided infrastructure to the resources, application, and the service to the consumers. So there are the various security issues with the SaaS, that is security of the data and the network, access locality, confidentiality breaches, integrations, and the segregation of the data. So the another one is authentication and authorization, web application security, virtualization vulnerability, availability backups, identity management, and the sign-in processes. Now, next slide is about the security issues with PaaS and IaaS. So the security issues with the PaaS is that the service provider may give some control to the individual to build application on the top of the platform. The provider has to assure that the data remains secure between the applications. Now, the security issues with the infrastructure as a service IaaS is that additionally, virtual machines could address these issues, yet, but there are many safety issues like physical security, environmental security, and the virtualization security. The consumer in turn is liable for the security controls that identify which the IT framework counting the operating system, application, and the data. So this is the machine learning. This slide is about the machine learning. Machine learning is a branch of artificial intelligence. It is used for data analysis, which branch of artificial intelligence can learn, identify the patterns between the data and making the decision with less involvement of the human. So there are two types of machine learning, is that supervised machine learning and unsupervised machine learning. And the supervised machine learning is a technique which needs to train the data, needs to training and the train themselves. And unsupervised machine learning is, in this technique, machine learning learns by itself with the examples. So there are the various technique which is used in this cloud security is.
Sorry to sir, just 1 minute left. Please, can you conclude also?
Sir, can I conclude? And so these are the literature survey which I have gone through, that in one paper they have find out this UNSW data set and IOSET data set, and they are getting this records and the normal records and the percentage of that affected records and the percentage of the accuracy. So the IOSET data set is the two different data set obtained from the HoneyNet projects, Storm and the Wildlife botnets for the detection of the defective traffic's dataset characteristics of IOSET dataset. So this is shown in this table. Now the accuracy they have conducted and find out the accuracy is that J48 shows the 84.6 true positive and the 15.2% of false negative, while naive-Bayes algorithm perform. So naive-Bayes algorithm perform worst case and give the 56.2 true positive and 43.8% false negative. So the logistic regression is giving the best performance, that is having 93.7%, and identify the true positive anomalous package 6.3% of the false negative erroneous cases. So the various in the various papers, they have conducted this ensemble-based multi-filter feature selection method by finding out this probabilities from this formulas, and like this entropy formula, this variable between A and B, this is finding the probability of the posterior probability of A and B. Now the information gain, and these are the intuition detection has another paper is showing that intuition detection has 3 different phases: monitoring, detection, and the response. The learning algorithm divides in the normal design into 2 aspects: a non-stationary model, which depends on the timestamp of last event occurring; another, monitoring of the intuition detection protocol, collecting of identifying to unknown malicious activities. So these all are the literature survey which I have find out. This the 2 phases classification method of the intuition detection method. Phases 1 use the k-means algorithm for clustering the set of patterns. In the second phase, the distance-based technique is used. K-means algorithm minimize the object functions by the squared error function. This is the squared error function which they have used. Now the conclusion is that in this paper, I have overviewed the different kind of ML techniques which are used in intuition detection system in the cloud computing, but still there is need to identify attributes which is responsible for the hacking of the data. The related work mentions many ML algorithm, but actually implementation of cloud is yet to be explored. So the help of the machine learning techniques experiment, we can make the intuition detections into the cloud computing area for the efficient and achieve cloud security. So the further future scope is including identifying challenges in the implementation and the further modifying the techniques. That's all from my side. And these are the references.
As sir has exhausted his time, so Geeta ma'am, a quick question if you have for sir.
Yes. Okay, how many papers you have studied, sir?
Ma'am, actually, I have gone through 15 to 16 papers, but the gist of this paper I have included in only 11 paper, because some of them are the survey paper, which are I am not getting any that attributes which are responsible for that cloud security. So that's why I have left that 5-6 papers and keep only 10 to 11 papers in this.
Okay. Thank you so much, sir. Thank
Thank
you.
you.
Okay, thank you so much, sir, and thank you, ma'am. So with this, we come to the end. Just before this, just a last call for Inian K and Harsh Modi. Are you there in the? Are you there with us? No, they aren't. So I think, ma'am, with this, we conclude. We conclude our session. Let me just share my screen. So thank you to all the authors for their excellent participation, presentation, contribution, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2024 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer and the publication will be live within 6 months. Kindly cooperate with the team of ICT4SD 2023. I also thank our session chair, Dr. Geeta Navle, for chairing the session, and a token of appreciation to the chair on behalf of team ICT4SD is here for you, ma'am. This is a token of appreciation for you on behalf of the team and Global Knowledge Research Foundation.
Yeah, thank you so much. Thank you so much.
Ma'am, do you want to say something before we end this session?
No, sir. No. Actually, just one thing that Raghav Simhan sir's presentation was very nice.
Okay.
And I would like to congratulate him. And please continue such a type of research in future. Yeah.
Okay,
Thank you. Thank you so much.
And now I request, please,
Thank
all
you.
can you turn on your cameras for a quick snapshot? So, Raghav Siman, sir.
I have turned it on. I think I'm having some permission issue in my browser. It's not turning on.
No problem.
It's fine.
We get it. So just this snapshot I'm taking. Okay. Thank you so much, everyone. Thank you, ma'am.
Thank you so much. Yeah.
Hope to see you next year. Have a great year.
Yes, yes, sure. Yeah.
Thank you so much.